Welcome viewers. In this video, we'll see the Ohm's law, definition, limitations and problems. First we'll see the Ohm's law. The Ohm's law states that current flowing through the electric circuit is proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit, then provided temperature remain constant. So what is the statement given? The current flowing through the circuit is directly proportional to potential difference across the circuit and inversely proportional to resistance of the circuit. I is directly proportional to V by R, directly proportional to potential, inversely proportional to resistance. So by cross multiplying this, we can write V equal to IR. That is a very basic formula in electrical. Voltage equal to current into resistance. Based on the Ohm's law, what we got? V equal to I into R. The important thing is the temperature remain constant. Because when the temperature changes, the resistivity, current, everything will change. So based on the condition temperature remain constant, then only this I equal to V by R, so that V equal to I into R. So temperature remain constant. Now we'll see the power expression for power from this Ohm's law. V equal to IR. The power is nothing but V into I, voltage into current. V into I, the power, we know that power equal to voltage into current. But based on the Ohm's law, what is V equal to IR? We will substitute this V equal to IR. So that power equal to IR into I. This V is replaced by IR. Then this I is written. So what will happen? I square R. So power can be expressed in a new formula is called I square R. The general formula is V into I. The V is substituted with IR. So that what we got? I square R. So the power in terms of current is nothing but I square R. Generally it is called as a power loss. Because the loss is depends upon the current, so this term is normally referred as a power loss. And one more expression, power equal to V into I, but based on the Ohm's law, V equal to IR, I equal to V by R. Now we'll substitute I equal to V by R. Previously we substituted V equal to IR. V is replaced. Now we will replace I. So I equal to V by R. So that power equal to V into I is nothing but V by R. So that V square by R. So another formula for power is in terms of voltage is V square by R. So we got two different expression for power. So this is a general expression, voltage into current. This expression based on current and resistance, I square R. This expression based on voltage and resistance, V square by R. So three different formula available based on our requirement, based on the data, we can use either any of this formula. Now we'll go to the limitations. What are the limitations of Ohm's law? The Ohm's law does not apply to all metallic, non-metallic conductors. So it is applicable only metallic conductors. Non-metallic conductors is not applicable. We cannot apply the Ohm's law to non-metallic conductors. It also does not apply to non-linear devices. Only applicable for linear devices. Linear devices mean when current increases, voltage also increases linearly. But in non-linear devices, we cannot apply the Ohm's law. The example is Zener diode. We cannot apply Zener diode. For non-linear devices, we cannot apply the Ohm's law. The third one, Ohm's law is true for metal conductors at constant temperature. We already discussed, if temperature changes, a voltage, current, everything property will change. So we cannot apply the Ohm's law. Only when the temperature is constant, then only we can apply the Ohm's law. If temperature changes, the law is not applicable. We cannot apply the Ohm's law. Right? So it is applicable only metal conductors under the constant temperature. Non-metal conductor is not possible. Non-linear device also not possible. So these are all the limitations of the Ohm's law. Now we'll see the resistance, resistivity. One more term is available, resistivity. We'll see now. We'll see this resistance. What are the property of the resistance? Resistance of a metallic conductor depends upon the following. The resistance of any metallic conductor having this following properties. One is directly proportional to length of the conductor. The resistance is directly proportional to length of the conductor. If length increases, the resistance also increases. It is inversely proportional to cross-sectional area of the conductor. The cross-sectional area, it is inversely proportional. When the cross-sectional area increases, resistance will decrease. And this depends upon the nature of the conductor. It depends upon the nature of the material of the conductor. Depends upon the material, the own property of the material. And it is depends upon the temperature of the conductor that we already discussed. Resistance is Ohm's law is applicable only constant temperature. So it is depends upon temperature also. So based on the above statement, it is clear that R is directly proportional to L by A. Directly proportional to length of the conductor, inversely proportional to area of the conductor. So while equating, we are introducing one constant called rho. Rho is nothing but resistivity. That is depends upon the nature of the material of the conductor. It is given by the manufacturer. Resistivity. One more term is called a resistivity. So that R equal to rho L by A. So we can find the resistance based on these three parameters. Resistivity, length of the conductor, area of the conductor. So this resistivity depends upon the material, nature of the material. So similar to resistivity, we have conductance. Resistance like that, the inverse one is the conductance. Resistance means opposing the flow of current. Conductance means it is allow the current to flow in the conductor. So the conductance G, the term is G. Conductance is the inducement to the flow of current. Hence conductance is the reciprocal of resistance. Resistance will oppose the flow of current, but conductance will inducement to the flow of current. So both are inversely proportional, reciprocal. Both are reciprocal. So G equal to 1 by R. Resistance, this is conductance. So now we discuss the resistance in terms of resistivity and conductance. Now we'll go for a problem. We'll solve three different problems. We'll see the first problem, problem 1. The resistance of a conductor 1 millimeter square in cross-sectional area and 20 meter long is 0.346 ohm. The resistance of the conductor is given 0.346. The area of cross section is 1 millimeter square. Then length is 20 meter. Determine the specific resistance of a conducting material, that is resistivity. We need to find the resistivity, right? The resistance, cross sectional area, length is given. We need to find the resistivity. So first we'll convert the given data into meter. So area equal to 1 millimeter square. In order to convert into meter square, 10 to the power minus 3. Meter to millimeter to meter means 10 to the power minus 3. Here meter square is there, millimeter square. So 10 to the power minus 6 meter square. So 1 into 10 to the power minus 6. So the millimeter square is converted into meter square. The length is 20 meter. Is already given in meter. The resistance is 0.346 ohm. These three data are available. So what we need to find? The resistivity. How will you find the resistivity? The formula available. R equal to rho L by A. Just now we discussed. R equal to rho L by A. So cross multiply this. R into A equal to rho L. Bring the L in the denominator. R A by L equal to rho. That is rho equal to R A by L. So from this formula, all these values are known. So we can find the rho. So it is rearranged in such a way that rho equal to R A by L. Now we can substitute the value of this R, A and L. R is 0.346. A is 1 into 10 to the power minus 6. The length is 20 meter. So by simplifying, what we got? 0.0173 into 10 to the power minus 6 ohm meter. The unit for resistivity is ohm meter. 0.0173 into 10 to the power minus 6. So we will move the decimal into two places, so that 1.73 into 10 to the power minus 8 ohm meter. Right? The decimal is moved to two places, so that this 10 to the power minus 6 become minus 8. This value increases means power also increases. 1.73 into 10 to the power minus 8 ohm meter. Right? So this very simple problem. In this formula, R is available, L is available, A is available, so that easily we can find the rho resistivity. Right? Now we'll go to the second problem. The second problem is the electric heater draws 80 ampere from 250 voltage supply. One electric heater is there, it will take the 8 amperes from the supply 250 voltage. What is the power rating? And also find the resistance of the heater element. Two questions we need to find. What is the power rating and what is the resistance of the heating element? So the given data, the current is drawn by is 8 ampere. Supply voltage 250 amperes. So these two data are available. Supply voltage and the current. What is the power rating? Power rating is nothing but V into I. Voltage into current. Voltage is 250, current is 8 ampere, so 2000 watts. The power rating of the heater is 2000 watts. V into I. What is the resistance R? R equal to V by I. Based on Ohm's law, V equal to IR. So R equal to V by I. V is 250, I is 8. So 250 by 8, 31.25 ohm. Is 31.2. The resistance of the heater element is 31.25 ohm. Right? So we calculated power rating as well as resistance of the heater element. Now we'll go to the next problem. We'll refer the third problem. What will be the current drawn by the lamp rated 250 voltage 40 watts connected to 230 volt supply? Right? So the one lamp is available. The rating of the lamp is 250 watts 250 volt 40 watts. We need to find what is the current taken by this lamp. It is connected across 230 volt. Since this 250 is the rating, this 230 is the supply voltage. It is connected across 230 voltage. Right? So what are the data available? Rated power is 40 watts. Rated voltage is 250 watts. Supply voltage is 230 watts, 230 volt. Now we'll find the what is the question. We need to find what is the current taken by the lamp. In order to find the current, first we will find the resistance R. R equal to V square by P, because the power is available. What is the formula relating power and resistance? Just to now be discussed. V equal to power equal to V into I, one formula. I square R, another formula. V square by R, another formula. So here V and P is available, so that we can use this formula. P equal to V square by R, from that R equal to V square by P. So V is 250 square divided by power rating 40, so that 1562.5 ohm. Right? From the given data, power and voltage, we calculated the resistance of the lamp is 1562.5 ohm. Right? So the power P equal to V square by R, from that R equal to V square by P. So now we got the value of current, resistance. Already supply voltage is available. So from this R and V, we can easily calculate the current. Current I equal to V by R. V is already given. Supply voltage 230. 250 is the rated voltage, but supply voltage only 250. Resistance now we calculated 1562.5 ohm. So we can substitute here. V equal to 230, R equal to 1562.5, so that 0.1472 amperes. So the current drawn by the lamp is 0.1472 ampere, right? So in this problem, power and voltage is given. From that we calculated the resistance. From the resistance we calculated the current drawn by the lamp. Now we'll go to the next problem. So the fourth problem is, a battery has an EMF of 12.8 voltage and supply a current of 3.24 ampere. One battery is available. The EMF of the battery is 12.8 voltage and current is 3.24 amperes. What is the resistance of the circuit? We need to find what is the resistance. How many coulomb leaves the battery in 5 minutes? How many coulombs leaves the battery in 5 minutes? The two questions we need to find, right? So what are the data available? The battery EMF is given, V equal to 12.8 voltage, and current is given 3.24 ampere. 3.24 ampere, the current is given, and time also given, 5 minutes. 5 minutes means 5 into 60 seconds. Converting into 6 seconds, we need to multiply 60. So the resistance can be easily calculated. R equal to V by I. The formula is there, R equal to V by I. That is V equal to IR. From that, R equal to V by I. Both are given. Voltage, EMF is given 12.8. Current is given 3.24 ohm. So this 12.8 by 3.24, what we got? 4 ohm. The resistance of the circuit is 4 ohm. And what is the charge leaving the battery? Charge is nothing but current into time in seconds. Current is 3.24. Time is 5 seconds, 5 minutes. 5 into 60 is a second, converted into seconds. So 5 into 60. 972 coulomb. So the charge leaving the battery in 5 minutes is 972 coulomb. Right? So in this problem, voltage, current and time is given. From that we calculated the resistance, voltage by current, and we calculated the charge using the formula current into time. Right? That is 4 ohm. This is 972 coulomb. So in this video we discuss about the Ohm's law, what is the definition and what is the formula. Then power in terms of resistance, V square R, I square by R, 2 times. Then limitations of Ohm's law. Then resistance, what are the property of the resistance. In this the important thing, resistivity. We discuss about the resistivity. The resistance means the reciprocal conductance, that also we discuss, and we discuss the 4 problem based on this Ohm's law. Thank you. Welcome viewers. In this video we will see the combination of resistor. The resistors can be connected in 2 different ways, either series or parallel. So we will see these one by one. First we will see the series combination. Series combination means the resistors are connected end to end. One end of the resistor connected to another end of the resistor, so that it is called a series combination. You can refer the diagram here. R1, R2, R3. 3 resistors are connected in series. One end of the resistor connected to another resistor, thereby another resistor. R1, R2, R3. This is called a series combination. It is given with a supply voltage V. The current flowing is I. This terminal is A. This terminal will be B. The important thing in this series combination is the same current is flowing through all 3 resistors. Current is same. Only one current I is flowing through R1, R2 and R3. Because of series combination, series connected, only the current I is flowing through all the resistors. This is the one important point. This V1 is the voltage drop across R1. V2 is the voltage drop across R2. V3 is voltage drop across R3. So the V is the applied voltage. This voltage will be dropped across R1, R2 and R3 depends upon the R value. So depends upon the R value, the voltage will be dropped. So this V1, V2, V3, sum of these three is nothing but total voltage. Total voltage V equal to V1 plus V2 plus V3, because this V only dropped across these three resistors. So V equal to V1, V2, V3. So the two important thing, one is current is equal in all the resistors. Second one, the voltage, applied voltage V equal to sum of V1, V2 and V3. That is V equal to V1 plus V2 plus V3. So these two are important points in this series combination. So these three resistors can be converted into single resistor, equivalent resistance, total resistance between the terminal A and B. Now we'll see what is the total resistance in case of seriously connected. We'll see the expression. How will you find the total resistance? So in this is given, the description is given, since there is only one closed loop, only one current is flowing, the first one. In other words, if the current is same through all the resistor, this combination is called a series combination. The series combination is easily identified. If the current is same in all the resistor, means the same current is flowing, means that resistors are connected in series combination. Now V is the applied voltage, I is the series current. V1, V2, V3 is nothing but voltage drop across resistor R1, R2, R3. First we will find what is the voltage across V1. V1 is nothing but I into R1. V equal to IR. V1 equal to I into R1. Voltage drop across the resistor R1, so that it is I into R1. Voltage drop across R2 is V2 equal to I R2. Similarly V3 is I R3. The current is same in all the cases, only the resistor and voltage will be different. The current is same. We already discussed the total voltage equal to V1 plus V2 plus V3. Voltage drop across R1, R2 and R3. That is the important thing in the series combination that we already discussed. The current is equal, potential is different, the sum of all potential is equal to total potential. Now we'll substitute this value. V1 is nothing but IR1, V2 is IR2, V3 is IR3. The current is same. So we'll take the current outside. V equal to I into the I is taken outside, so that R1 plus R2 plus R3. So this R1 plus R2 plus R3 is nothing but a total resistance, RT. RT is nothing but R1 plus R2 plus R3. So in the series combination, the total resistance is nothing but sum of individual resistance. So the series combination means very simple. We need to add all the individual resistance. That will give the total resistance. So that is given. The total resistance is equal to the sum of the individual resistors. We need to add all the resistors, right? So in this series combination, first important point is the current is equal. Same amount of current is flowing. Potential drop across each resistor, sum of potential drop across each resistor is total potential, V equal to V1 plus V2 plus V3. So by analyzing, we found that the total resistance equal to sum of individual resistance for series combination. Now we'll go to the parallel combination. What is parallel combination? If one end of all the resistor is joined to a common point and other ends are joined to the another common point, then the combination is said to be parallel combination between the two common points. The one end of all the resistors are connected in one common point, another end is connected to another common point, then that combination is said to be parallel. Now I will refer this diagram so that it is easier. See that the three resistors available, R1, R2, R3. This one end of all the resistors are connected together. This is common point A. Another end also connected together. Another end of all the 3 resistors are connected together. This is point B. So this is common point, another common point. Right? In series resistor means it is connected end to end, but parallel combination it is connected, one ends are connected together, another ends are connected together. This end is A, this end is B. It is supplied with the supply voltage V. Supply voltage V is given. This is the current, total current I is flowing through the resistor. I is flowing through the circuit. So the current I is flowing. At this point what will happen? The current will be divided because 3 different paths available. So the current will be divided. I1, I2, I3. Current is divided. In case of series combination, the voltage is divided. Now the current is splitted. Current flowing through R1 is I1, R2 is I2, R3 is I3. So total current I equal to I1 plus I2 plus I3. So there is an important thing in this parallel combination. In series combination, V equal to V1 plus V2 plus V3. But here the current is total current equal to sum of current flowing through each resistor. What about the voltage? The same voltage is applied across R1, R2 and R3. The voltage what we applied V is available across R3, R2 as well as R1. The voltage will be same. The current will be different. So this parallel combination can be converted into single resistor, total resistor or equivalent resistor between A and B with a supply voltage V. We will see what is the resistance R. How will you find what is the expression for total resistance in case of parallel combination? We will see now. So V is the applied voltage. I1 and I2, I3 is the current flowing through R1, R2 and R3. So by Ohm's law we will find the I value. I equal to I1 equal to V by R1. I already told V is same across all the resistor. Only the current will be different. So I1 is the current flowing through resistor R1. So I1 equal to V by R1. Similarly I2 equal to V by R2. I3 equal to V by R3. And another important thing, total current equal to sum of this current flowing through the resistors. Previous in the series combination, V equal to V1 plus V2 plus V3. Here I equal to I1 plus I2 plus I3. Now substitute the value V by R1 plus V by R2 plus V by R3. The voltage is common, so we can take the voltage outside. So what we have? I equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So this is nothing but the total resistance 1 by RT. So I equal to V into 1 by RT. So that we can write I equal to V by RT. So what is this RT is nothing but 1 by R1 plus 1 by R2 plus 1 by R3. Now we'll see the further simplification. So 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. So now we'll go for a simplification. We'll take the LCM. 1 by RT equal to, so the R1, R2, R3, 3 terms available. So we will take the LCM as R1, R2, R3, all 3. So here R1 is available, R2 and R3 is not available. So it is R2 plus R3. Here R2 is available in the common LCM. So R1 and R3 is multiplied here. Plus here R3 is available. So R1 and R2 is multiplied. So it is R2 R3 plus R1 R3 plus R1 R2 divided by R1 R2 R3. So this is 1 by RT. What about RT total resistance? It is inverse. Just you have to change the numerator and denominator. So R1 R2 R3 divided by R1 R2 R2 R3 plus R3 R1. So this is the total resistance in case of the parallel combination. The 3 resistors. Suppose the 2 resistors are available. What is the total resistance? Two resistors are available. 1 by R2 equal to 1 by R1 plus 1 by R2. Only two resistors. Normally we will refer the two resistors. This formula only we are frequently using. So 1 by RT equal to, take the LCM, R1, R2, two terms available. Here R1 is there, so we need to multiply with R2. Here R2 is there, so we need to multiply with R1. So this is 1 by RT. What is RT? Just you have to interchange numerator and denominator, reciprocal. You have to take the reciprocal. So R1, R2 divided by R1 plus R2. So this is a standard formula. In case of parallel combination, the resultant or equivalent or total resistance is R1 R2 divided by R1 plus R2. Multiply both the resistor divided by sum of both the resistors. R1 R2 divided by R1 plus R2. So now we got the expression for total resistance in case of parallel combination for 3 resistor as well as 2 resistor. Now we'll see one problem. So in this problem, we need to calculate the equivalent resistance of the following combination of resistor and also source current. So one circuit diagram is given. In this, we need to find what is the total resistance and also what is the total current, source current. So here 12 ohm resistor available, 16 ohm and 4 ohm. There is another 6 ohm available and 40 ohm available. Now we need to simplify this resistor by using this series parallel combination. By using series parallel combination, we can simplify this circuit. So in this circuit, it is, by seeing this, it is clear these two are connected in parallel. By seeing the diagram, it is very clear that 12 ohm and 6 ohm are connected in parallel. There is no overlap here. Suppose we cannot take this because this is connected another 40 ohm, here 6 ohm is there. Here there is no overlap. This 12 ohm and 6 ohm are connected in parallel. Now we'll change this. Now we'll find the equivalent resistance for this 12 ohm and 16 ohm. Right. So that diagram is available here. See this. This 12 ohm and 6 ohm are connected in parallel. We'll take this is R1 and this is R2. What is the total resistance in case of two resistors connected in parallel? R1 into R2 divided by R1 plus R2. So that is equal to 12 into 6 divided by 12 plus 6. That is 72 divided by 18. It is 4 ohm. So the combination of these two resistors are parallel, right? While simplifying this, what we got is a 4 ohm. These two resistors connected in parallel. By finding the total resistance, it is 4 ohm. So this parallel combination can be replaced with a single resistor of 4 ohm. This 4 ohm, right? This 4 ohm is replaced, right? So the 12 ohm and 6 ohm resistors connected in parallel, that equivalent resistance we calculated 4 ohm, so that it is replaced with 4 ohm. Now by seeing this diagram, it is very clear this 4 ohm and 16 ohm are connected in series. There is no overlap. Easily we can identify these two are in series. Right. Now we'll go for the further simplification. See this 4 ohm and 16 ohm. This 4 ohm and 16. We'll take this R1 and R2. So if the resistors are connected in series, what is the total resistance? R1 plus R2. We need to add both the resistor. 4 ohm plus 16 ohm. That is 20 ohm. Right. So the 4 ohm and 60 ohm are connected in series, mean the total resistance is 4 plus 16, 20 ohm. So this combination now replaced with a single resistor 20 ohm. We have one more resistor available, 40 ohm. So that is connected between 16 and 4 ohm. So by seeing this diagram, it is very clear this 20 ohm and 40 ohm are connected in parallel. There is no overlap. These two are connected in parallel now. Now we can replace this with a single resistor. I will go for this further. See this 20 ohm and 40 ohm are connected in parallel. What is the formula? RT equal to R1 R2 divided by R1 plus R2. For simplification, we are taking this R1 and R2, right? This is not, there is no standard. This for this combination we are taking 20 ohm as R1, 40 ohm as R2. So 20 into 40 divided by 20 plus 40. So that is equal to 800 divided by 60, that is equal to 13.33 ohm. 13.33 ohm. The combination, parallel combination of this 20 ohm and 40 ohm, the equivalent resistance is 13.33 ohm. So this 20-40, this combination can be replaced with this 13.33 ohm. This is replaced. That parallel combination is replaced with 13.33 ohm. Here another 4 ohm is available. So by seeing this diagram, it is clear these two are connected in series. The equivalent resistance is sum of these two. 13.33 plus 4 is nothing but 17.33. Right, now we'll see this diagram. So this 17.33 ohm, then supply voltage is 50 volt and the current is I. Now it is converted into only single resistor. Right, the every series and parallel combination resistors are combined resistors are identified, and finally we got only one resistor. So from this diagram we can easily identify what is the current. Right. So the total resistance is nothing but 17.33 ohm. One question is total resistance. So we calculated total resistance equal to 17.33 ohm. Then what is the current? I equal to V by R. V is available and R also available. V is 50 volt and R is 17.33 ohm. So we can find the total current or source current, that is equal to V by R. V is 50, R is 17.33. So that after simplification we got 2.88 ampere. So the total current or source current is 2.88 ampere. So in this problem there are series and parallel connector resistors are there, that is simplified and equivalent resistance is calculated. Finally we got only one resistor, total resistance of 13.33 ohm. From that we calculated total current or source current also. So in this video we discuss about the series combination of resistor, what is the equivalent formula, parallel combination of resistor, what is the equivalent formula. Based on that we solved one problem. Thank you. Welcome viewers. In this video we will see the problem related to the series and parallel combination of resistor. The detailed explanation of series and parallel combination of resistor, the derivation and explanation available in previous video. The link is available in the description box. You can see the detailed explanation of the series and parallel combination. This video related to the problem based on series and parallel combination of resistor. First we will see the formula. The series combination. If the resistors are connected in series, mean the resultant resistance will be R1 plus R2 plus R3. If three resistors are connected in series, mean the resultant resistance is total resistance is nothing but sum of individual resistance. You have to add all the resistors, R1 plus R2 plus R3. In case of parallel combination, if three resistors are connected in parallel, the resultant value will be R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. Suppose the two resistors are connected, mean R1 R2 divided by R1 plus R2. So based on this formula we will go for the problem. The detailed explanation available in previous video, you can see that the link is available in the description box. Now we'll go to the problem 1. So the circuit is available. In this circuit diagram we need to find the equivalent resistance and current flowing through a source of 12 voltage for the circuit shown below. So for this circuit diagram, the combination of resistors available, we need to find what is the total resistance, equivalent resistance, as well as what is the current flowing through this the source 12 voltage. Now we'll see this. How will you find the series and parallel resistor? If the current flow, the same current is flowing through the resistor, that resistors are connected in series. If the current is diverted at this point, that means that two resistors are connected in parallel. So based on the current value, we can easily identify whether it is connected in series or whether it is connected in parallel, right? If the same current flowing means series. If the current is diverted means parallel, right? So we start from here. We'll say that the current is I1. The current flowing through the source, 12 volt source, is I1. So the I1 is flowing through 25 ohm. So at this point, what will happen? The current will divert. Because of branch, it is diverted. I2, I3. What is the meaning? These two resistors are connected in parallel, right? This 100 ohm and 50 ohm are connected in parallel. Again, this I2 is flowing through 100 ohm. At this point, again the current is diverted. This I5, I4. What is the meaning? This I4, I5. So this 5 ohm and 10 ohm, these two are connected in parallel, right? So these two are connected in parallel. These two are also connected in parallel. So by seeing the current flow, we can easily identify. So the I1 is flowing through 25 ohm, that is divided into I2 and I3 through 100 ohm and 50 ohm. Again that is divided into I4 and I5 through 5 ohm and 10 ohm. So these two are parallel and these two are parallel. Now how will you simplify this? So in this circuit diagram, this type of circuit diagram, we have to follow from the load end, opposite to the source. We cannot simplify from this source end. We can follow from this opposite to the source end. Normally it may be taken as a load end. From load to source we need to follow. We cannot simplify from source to the load. We need to follow from this side to source, right? We need to follow from this end. So first we will follow this end. That is, these two are connected in parallel. We will go from right hand side to left hand side. Right? So by seeing this diagram, it is clear these two are connected in parallel. So if these two are connected in parallel, we can find the equivalent resistance. So that calculation available here. So this 5 ohm and 10 ohm are connected in parallel. This 5 ohm and 10 ohm. We'll take this is R1 and R2. For simplification purpose, we assume that 5 ohm is R1, 10 ohm is R2. What is the total resistance? R1, R2 divided by R1 plus R2. So this is the formula for when two resistors are connected in parallel. So what is that? 5 into 10 divided by 5 plus 10. That is 50 divided by 15, 3.33 ohm. Resultant will be 3.33 ohm. So these two resistors are connected in parallel. By inspecting the current, we easily identify these two are in parallel. So the equivalent resistance of these two parallel resistor is 3.33 ohm, right? Now we can replace these two with 3.33 ohm, right? That is available in the next diagram. See this, right? That parallel combination now converted into 3.33 ohm. What we calculated is replaced. Now from this diagram, it is clear that these two are in series. See, the same current is flowing through 100 ohm as well as 3.33 ohm. The same current is flowing. What is the meaning? These two are connected in series. If series mean R1 plus R2, we will take 100 as R1, 3.33 as R2. So the resultant, if it is connected in series, R1 plus R2, 100 plus 3.33 ohm, that is 103.33 ohm. These two are in series. The equivalent resistance will be 103.33 ohm. Now we'll replace this with this value. So after replacing, what we got? 103.33 ohm. So these two are other two resistors available. So from this diagram, it is easily we are able to understand these two are in parallel because the current is diverted here. Current flowing through 25 ohm is diverted here. So these two are in parallel. Now if we take this 103.33 as R1, 50 ohm is R1 and 103.33 as R2. Now we'll find the equivalent resistance. What is the equivalent if it is connected in parallel? R1 R2 divided by R1 plus R2. 50 into 103.33 divided by 50 plus 103.33. So that is 5166.5 divided by 153.33. So that is nothing but 33.69. These two resistors connected in parallel, the equivalent resistance will be 33.69 ohm. So now we can replace these two parallel resistor with single resistor 33.69. So that is replaced here. 33.69. Now from this diagram it is clear these two are in series. The same current is flowing through 25 as well as this 33.69 ohm. So what is the resultant sum of these two, R1 plus R2? We'll take this 25 ohm as R1, 33.69 as R2. So 25 plus 33.69 is 58.69 ohm. So these two parallel combination can be replaced with a single resistor 58.69, right? So for the simplified diagram is available here. See this, now it is replaced with 58.69. So this is the total resistance. Step by step we find the equivalent resistance by using series and parallel combination. Finally what we got, 58.69 ohm. So that is nothing but the total resistance. One more question, we need to find total current or source current. I equal to V by RT. V, applied voltage divided by total resistance. So 12 divided by 58.69. The supply voltage is 12 and the resistor is 58.69. So it is 0.204 amperes. So the current is 0.204 amperes. So in this problem, by solving the problem step by step using a series parallel combination, finally we got the answer. The equivalent resistance of the circuit is 58.69 and the source current or total current is 0.204 amperes. Now we'll go to the next problem. So in the second problem, we need to find the total power dissipated in the circuit zone is 18 watts. The total power in the entire circuit is 18 watts. Find the value of resistance and current in the circuit, right? So in this diagram, the 12 voltage is applied to these two resistors, the set of resistor. These two resistors are, we can easily see the parallel. These two resistors are another parallel combination. This 8 ohm, this resistor value is not known. Another parallel combination 4 ohm and 16 ohm, right? So the total voltage is available, 3 resistors value is available and 1 resistor value not available. So we need to find what is this resistor value and also what is the current. One more value what we have, the total power dissipated in the entire circuit is 18 watts. We have one more data, what is available as total power is available. So by using the total power and other terms, we need to find what is this total resistance and what is the total current. Now we'll follow with the total power. What is the total power formula? V square by R. Total power equal to V is two formula available. I square R or V square by R. Right? Here we can use V square by R because the total power is available, voltage is available. So easily we can find the total resistance. I square R we cannot follow because I square means the current value is not available. So the total power is 18, voltage applied is 12 square divided by RT, total resistance. You cross multiply, interchange these two values. So RT equal to 12 square by 18, that is 144 by 18, that is RT equal to 8 ohm. So now we got the total resistance of the circuit is 8 ohm. From the total resistance we can easily calculate the total current. I equal to V by RT. V is available 12 voltage, RT is 8 ohm, so it is 1.5 amperes, right? So we got the total power by using the formula. We got total resistance. From the total resistance we calculated the total current 1.5 ampere. So the one question is identified. Another question, we need to find the R value. The R value is not available. This is the total resistance. One resistor value is not known. We need to find the total resistance. I will go for that. So from the diagram it is clear 8 ohm and R are connected in parallel, that we already discussed. 4 ohm and 16 ohm are connected in parallel, and these two are connected in series. Two parallel combination that is connected in series. So what is the total resistance? This is first parallel combination, 8 R1 R2 divided by R1 plus R2, 8 into R divided by 8 plus R. Similarly, another parallel combination, R1 R2 divided by R1 plus R2, 4 into 16 divided by 4 plus 16, right? So this R value is not known, but this RT is we calculated. RT is 8 ohm, right? This 8 ohm is calculated, RT value is available. So in this equation only this parameter is not known, other things are available, so you can easily find the value of R, right? Now we'll go for the simplification. I will substitute this RT equal to 8 ohm. So 8 equal to 8R divided by 8 plus R, that is 64 divided by 20. Now go for further simplification. 8 equal to 8R divided by 8 plus R plus 64 divided by 20 is 3.2. Now bring this 3.2 in the left hand side. So 8 minus 3.2, this plus 3.2 become minus 3.2 equal to 8R divided by 8 plus R. So 8 minus 3.2 is 4.8, that is equal to 8R divided by 8 plus R. Now we'll go for the further simplification. Now cross multiply this, so that 4.8 into 8 plus R equal to 8R. Now multiply this, 4.8 into 8 plus 4.8 into R, that is equal to 8R. So 4 into 8 is 38.4 plus 4.8 R equal to 8R. 38 plus 38.4, bring this 4.8 in the right hand side, so that 8R minus 4.8R, while going this side it will become minus, so that 38.4 equal to this 8 minus 4.8 is 3.2R. So 3.2R can be 38.4, it is interchanged. For simplification, 3.2R equal to 38.4, both are interchanged. So R equal to 38.4, bring this 3.2 in the denominator, 38.4 divided by 3.2. So R equal to 12 ohm, right? So from series parallel combination, we calculated the total, the resistance, unknown resistance is 12 ohm. So in this problem, from the given total power, we calculated total resistance of the circuit, then total current. From the combination of resistor, we already know the total resistance, so that the unknown resistance R value is calculated. Now we'll go to the next problem. So in the third problem, there are three resistors available, 30 ohm, 25 ohm and 40 ohm. You can easily see that these are connected in series. The applied voltage is 200 voltage. So we'll take this is R1, 30 ohm is R1, 25 ohm is R2, 45 ohm is R3. The voltage drop across this 30 ohm is V1. Voltage drop across 25 ohm is V2. Voltage drop across 45 ohm is V3. Right? What is the question? Total resistance. We need to find what is the total resistance. What is the total current? What is the potential difference across each element, each resistance, right? Total resistance, total current and potential drop across each element, that is V1, V2, V3. How will you find the total resistance? It is easy. If it is connected in series, the total resistance equal to sum of individual resistance. RT equal to R1 plus R2 plus R3. 30 plus 25 plus 45, that is equal to 100 ohm. Right. Then what is the total current? I equal to V by R. V is 200 voltage. R is now all we calculated is 100. So 200 by 100 equal to 2 amperes. So we have easily calculated total resistance, that is sum of individual resistor. From RT value, by using V by RT, we calculated total current also. Now we'll go to the potential drop across each element. That is also very easy. V1 equal to I into R1, because current is same in entire series circuit. So the current will be I. Potential drop across R1 is V1, R2 is V2, R3 is V3. So V1 equal to I into R1, that is I is 2 ampere, we will calculate it, into R1. R1 value is 30. 2 into 30, 60 voltage. V2 equal to I into R2. I is 2 ohm, 2 ampere into R2 value is 25, that is 50 volt. V3 equal to I into R3. The I value is 2 ampere into 45, 90 voltage. Right. So the potential drop across V1 is 60 voltage, V2 is 50 voltage, V3 is 90 voltage. By adding all this, we got 200 voltage, because the 200 is the applied voltage. So by adding this, we got 200. So the answer what we calculated is correct. So in this problem, we discussed what is the total resistance, then total current, and potential drop across each resistor. So in this video, we discussed the 3 different problems related to the series and parallel combination of resistor. The series and parallel combination of resistor, the derivation available in previous video. Link is available in the description. You can see that. Thank you. Welcome viewers. In this video, we will see the source transformation, that is current source into voltage source and voltage source into current source. The voltage and current source may be interchanged without affecting the remainder of the circuit. This technique is called a source transformation. We can convert the voltage source into current source into voltage source without affecting the remaining of the circuit. This simplification is needed for the circuit some calculation, so that we are doing the voltage source to current source conversion and current source to voltage source conversion. This is called a source transformation. Any practical voltage source consists of an internal voltage source in series with the internal resistance. So practical voltage source is nothing but voltage source having some internal resistance, that is connected in series with the voltage source. So the voltage source in series with the internal resistor is a practical voltage source. Similarly, any current source also having the resistor that is connected in parallel with the current source. Any practical current source consists of an ideal current source in parallel with its internal resistance. So internal resistor available in both voltage source and current source. In case of voltage source, internal resistor is connected in series with the voltage source. In case of current source, the internal resistance is connected in parallel with the current source. Voltage source in series with the internal resistance, current source in parallel with the internal resistance are called a practical sources. So based on this, therefore any practical voltage source, that is ideal source V and internal resistance R, the voltage source can be replaced by equivalent practical current source. What is practical current source? Ideal source with internal resistance in parallel. So voltage source in series with the internal resistance can be converted into current source in parallel with the internal source, and vice versa is possible, right? So we need to remember that the internal resistor connected in series with the voltage source, in parallel with the current source. Based on that, we can go for the transformation. First, we will see the voltage source to current source. So the voltage source in series with the internal resistor is connected. This is called a practical voltage source. How will you convert into current source? Current source means the internal resistor is connected in parallel. So voltage source in series with the resistor can be converted, transferred into current source in parallel with the resistor. So this R is equal for both the cases, for voltage source as well as current source. Then how will you find the current I? I equal to V by R. V and R is available. From that we can calculate the current. Current I equal to V divided by R. We will see one example. So here one voltage source is available in series with the internal resistance 3 ohm is there. So this voltage source can be converted into current source in parallel with this 3 ohm internal resistor. So the 3 ohm resistor is now connected parallel. Voltage source is converted into current source. What is this current value? I equal to V by R. V is nothing but 90 voltage. R is 3 ohm. So 90 by 3, 30 ampere. So we calculated the current source value is 30 ampere. Right? So this is the conversion of voltage source to current source. Then we'll go to the current source to voltage source. So current source in parallel with the internal resistance can be converted into voltage source in series with the internal resistance. Right? Then how will you find V? V equal to I into R. I and R values are available. So V can be calculated as I into R. We will see one example. So here 5 ampere current source is available. Internal resistance 3 ohm is connected in parallel. So that can be converted into voltage source in series with the internal resistor 3 ohm. Then how will you find this voltage? V equal to I into R. So I is 5 ampere, R is 3 ohm. So 5 into 3, 15 voltage. Right? So current source in parallel with the internal resistor now converted into voltage source in parallel with in series with the internal resistance. Now we'll see some more problems. Now we'll see the problem 1. So in this problem there are 3 voltage sources available: 100 voltage, 50 voltage and 60 voltage. For each voltage source the internal resistor also available. This is 1 ohm, 0.5 ohm and 0.8 ohm. So this can be converted into single voltage source and single resistor. How will you find this single voltage and resistor? So the total voltage is nothing but sum of these 3. We can find the total voltage from these 3 sources: 100, 50 and 60. We need to see the polarity. What is the polarity? See here, negative, positive. Here, negative, positive. So these are all connected in series. But while going to here, positive and negative. Right? Polarity now changed. Series mean we need to go like this. Plus, minus, plus, minus, plus, minus, plus mean it is connected in series. We can add. This minus, plus, with these two are added together. 100 plus 50. But while going this third source is plus minus. This polarity is changed. So it is minus 60. Right? These two are connected in series, but this one is opposing. Right? So 100 plus 50 minus 60. If it is minus plus mean it is, we can add it as it is. If any polarity changed, minus plus and plus minus mean we need to subtract. So 100 plus 50, 150, plus from that you have to subtract minus 60 mean 90 voltage. The resultant voltage will be 90. What about the resistor? Resistor we can add as it is because all resistors are connected in series. So we can add all the resistor. That is 1 ohm, 0.5 ohm and 8 ohm. This 2.3 ohm. So the total resistance will be 2.3 ohm. So this is a problem having 3 voltage source with 3 internal resistor that will be converted into single voltage source and single resistor. Right? The resistors added as it is because it is connected in series. But while finding the total voltage, we need to see the polarity. Right? We need to show the polarity. So these two are same polarity, but here the polarity changed, so this is subtracted, these two are added together. Now we'll go to the second problem. So in this, 3 current sources are available. In the second problem, 3 current sources, 6 ampere, 1 ampere and 2 ampere. In current source means the internal resistor will be connected in series. This 1 ampere, for this 1 ampere, for this 2 ampere is available. Now we need to convert this current source into single current source and single resistor. How will you find the total current? Total current is nothing but see the direction. So this is upward, this is also upward, this will be downward. So this is rising current, may be taken as the positive current, these two are, this is negative current. So 6 plus 1 minus 2, we can easily identify which one is positive and which one is negative current from the direction. These two are going upward direction, so taken as positive, 6 plus 1. This one is going down, so minus 2. 6 plus 1, 7. 7 minus 2, 5 ampere. The total current will be 5 ampere. Right? In previous problem, while adding voltage, we see the polarity. In this problem, while adding the current source, we need to see the direction. Based on the direction, we can find. Then what is the total resistance? These two resistors are connected in parallel. So by using the parallel combination, we can find the resistance. We take this is the 1 ohm is R1, 2 ohm is R2. So the total combination while connected in parallel is nothing but R1 R2 divided by R1 plus R2. So 1 into 2 divided by 1 plus 2. 2 divided by 3, 0.67 ohm. Right? The resultant resistance will be 0.67 ohm. Right? So 3 current sources now converted into single current source with a single resistance of 0.67 ohm. Now we'll go to the next problem. So in the third problem, 2 current sources and 1 voltage source is available. In the problem 1, we have 3 voltage sources that will be converted into single voltage source. In second problem, we consider 3 current source that will be converted into single current source. In the third problem, we have 2 current source and voltage source. Both are available. Both current source and voltage sources are considered here. Right. Now we'll convert this entire circuit into single voltage source and single resistor. We can convert to single current source also, right? But in this problem, is converted into single voltage source with single resistor. That is, these 2 voltage sources are converted in, these 2 current sources are converted into voltage source, and final 1 voltage source is reduced. But in another way, we can convert this into current source. We will convert everything into a single current source also. Right. Now, in order to get the single voltage source, now we are going to convert these 2 current source into single current source. See this direction, both are upward direction. So the total current will be sum of these 2, 5 ampere plus 7 ampere. That is 12 ampere. How will you find the resistance? These 2 resistors are connected in parallel. What is the formula? R1 into R2 divided by R1 plus R2. This R1 is 3 ohm, R2 is 6 ohm. So 3 into 6 divided by 3 plus 6. So 18 divided by 9 is 2 ampere. Right. So these 2 current sources with 2 internal resistors now converted into single current source with 12 ampere with the equivalent resistance of 2 ohm. Right. Now we can reduce this diagram. See this. Now it is converted into single voltage, single current source 12 ampere with 12 ampere and single resistor 2 ohm. Right. Now what we have, this one current source available and one voltage source also available. Now our final aim is to find a single voltage source. So now we'll convert this current source into voltage source. How will we convert this current source into voltage source? So the current source in parallel with the resistor can be converted into voltage source in series with the resistor. Right, like this. So it can be converted into voltage source in series with the resistor 2 ohm. So 2 ohm. Then how will you find this voltage V? V is nothing but I into R. I and R is available. Current is 12 ohm, 12 ampere, and R is 2 ohm. So 12 into 2, 24. So we can get the 24 voltage here, right? So 12 ampere with 2 ohm internal resistor now converted into 24 volt in series with the internal resistor of 2 ohm. This 24 is calculated here. Now we have two voltage sources and two resistors that can be easily converted into single voltage source. Now see the polarity. What is the polarity of this circuit? This is plus, minus, plus, plus, minus. Now changed. If it is series mean minus, plus, minus, plus, minus, plus, it will go like that. If it is minus, plus, plus, minus mean both are opposing. So 24, this 24 minus 10, 14 voltage. The resultant will be 14 voltage. What is the resistor? These two resistors are connected in series. So 2 plus 2, 4 ohm. The resultant resistor will be 4 ohm. Right? So these two resistors opposing these two voltage sources connected in reverse direction, so that 24 minus 10, 14 voltage. These two connected in series, so 2 plus 2, 4 ohm. So this is the final value, simplified diagram. Two current source and one voltage source now converted into single voltage source and single resistor. Right? So in this video we discuss about the source transformation, voltage source to current source to voltage source, the formula, and we discuss the three problems. Thank you. Welcome viewers. In this video we'll see the voltage and current division rule. First we'll see the voltage division rule. Here the two resistors are connected in series, R1 and R2, which is energized by the DC voltage V. So what will happen? This voltage, some of the voltage will be dropped across R1, some of the voltage will be dropped across R2. Depends upon the resistor value. Depends upon the resistor value, voltage will be dropped across R1 and R2. So the voltage across R1 is V1. Voltage across R2 is V2. What is the value? The V equal to V1 plus V2. That is the first formula we need to check. The total voltage applied equal to sum of voltage drop across R1 and R2. Similarly, what is the current? The same current is flowing through R1 and R2. How will you find this V1? V1 equals nothing but current, that the current I into R1. V equal to IR. So I is nothing but total current I, R is nothing but R1. Similarly, how will you find V2? V2 equal to I into R2. Based on that, we can find. Now we'll see the description. In the series circuit act as a voltage divider. That is, since the same current is flowing through each resistor, voltage drop are proportional to the value of resistor. So the same current is flowing, but what about the voltage drop? That is depends upon the value of the resistor. So the series circuit means it is act as a voltage divider. Series circuit, the current is same, voltage will be dropped across that. So it is act as a termed as voltage divider. Using this principle, different voltages are obtained from a single source are called a voltage divider. That is, this V equal to sum of V1 and V2. Based on that, we'll go for the derivation. What is the total current? I equal to V by R1 plus R2. So this is the total current, that is equal to V by R. V is the applied voltage, R is two resistors available, so R1 plus R2. Right? Then what about V1? V equal to IR. I into R1. V1 means voltage across the resistor R1, so that I into R1. So in this, what is I? You can substitute the I value here. I is nothing but V divided by R1 plus R2 into R1. So this I value is substituted here. So that can be rewrite as V1 equal to R1 divided by R1 plus R2 into V. V1 equal to R1 divided by R1 plus R2 into V. What is this? Voltage across resistor R1 equal to total voltage multiplied by that resistor R1 divided by total resistor. So that is the general formula. The voltage drop across R1 equal to R1 value divided by total resistance into total voltage. From that is a formula. Similarly, V2 equal to I into R2. V2, what is V2? V2 is the voltage drop across resistor R2. So that is equal to I into R2. I is the same current, only one current into resistor. This I can be replaced with this value. I is nothing but V divided by R1 plus R2 into this R2. So R2 divided by R1 plus R2 into V. So voltage drop across the resistor R2 is nothing but the resistor value of R2 divided by total resistance into the applied voltage, right? So from this we can see the general formula. Voltage drop across the interested branch, that is which branch is called interested branch, is branch resistance. Which resistor we need a voltage drop, that resistance divided by total resistance into applied voltage, right? So this is the general formula. So voltage drop across interested resistor is nothing but branch resistance divided by total resistance multiplied by applied voltage. So based on that, we'll see one example. See here, the two resistors are connected, 100 ohm and 15 ohm. Sorry, 10 ohm and 15 ohm. It is energized by the DC supply, 100 voltage DC supply. They take this 10 ohm as R1, 15 ohm as R2. The voltage drop across R1 is V1, R2 is V2. Now we need to find what is the value of V1 and what is the value of V2 based on the voltage divider rule. So what is the V1? Equal to total voltage, that is applied voltage, multiplied by the resistor value divided by total resistor, right? So that V1 equal to the total voltage applied is 100 multiplied by 10 ohm. The V1 is nothing but voltage across the 10 ohm. So 10 ohm. Which one we need voltage? That resistor divided by total resistor. 10 plus 15. 10 plus 15. Right? So 100 into 10 divided by 25. So this 4 times available. 4 into 10, 40 voltage. So the voltage drop across V1 is 40 voltage. So by using the voltage divider we calculated. Similarly V2. V2 equal to same thing. Total voltage multiplied by resistor of that voltage. Which one we need? That resistor divided by total resistor. So V2 is the voltage across resistor R2. So that here we need to use R2. So V2 equal to 100 into R2 value is 15 divided by 10 plus 15, that is equal to 100 into 15 by 25. So here 4 times. So 4 into 15, 60 voltage. So see this, the sum of these two is 100 voltage because the applied voltage is 100. So in that 40 voltage is dropped across 10 ohm resistor, 60 voltage dropped across 15 ohm resistor. So the less value of ohm, the less voltage will be dropped. For more value of resistor, more voltage is dropped. So sum of these two is the applied voltage. Now we'll go to the current divider rule. So the current division rule, will see that here two resistors are connected in parallel. The previous voltage divider rule, or the resistors are connected in series, then only the voltage will be dropped. For applying the current division rule, the current resistor should be connected in parallel, then only the current will be diverted. Right? So here the voltage V is applied, the total current is I. The two resistors are connected in parallel, R1 and R2. So what will happen? The current will be diverted through R1 and R2. we'll take this is I1, this is I2. So the total current I equal to I1 plus I2. Depends upon the resistor value, sum of the current will diverted through R1, remaining current diverted to R2. So in parallel circuit, the current divides in all the branches. So the parallel circuit acts as a current divider. Previously the series circuit acts as a voltage divider. Here the parallel circuit acts as a current divider. So the total current I equal to I1 plus I2. That is a very basic formula. The total current entering into the parallel branches divided into branch current according to the resistor value. Based on the resistor value, the current will be divided. So we'll go for the derivation. So the basic thing is I equal to I1 plus I2. Total current equal to current flowing through the resistor I1 and I2. So I1 R1 equal to I2 R2 because the potential across both the resistors are equal. So in this diagram, the same voltage is applied through R1 as well as R2. So voltage across R1 is also V, voltage across R2 also V. Only the current is changes. So based on that, we can write I1 R1 equal to I2 R2. So from that, I2 equal to, bring this R2 here, I1 R1 divided by R2. So based on the voltage drop across both the resistors are equal, we formed this equation. From that we calculated I2. We know that I equal to I1 plus I2. In that you substitute this I2 here. This value is substituted here, so that I1 plus I1 R1 divided by R2. So this I2 is replaced by this value. Now take this I1 common. I1 is available in both the terms. So 1 plus R1 divided by R2. You take the LCM. So here nothing available, so this value will be multiplied here, R2 plus R1. So finally what we got, R2 I equal to I1 plus R1 plus R2. This R2 is multiplied here. This R2 is brought to the numerator. From that, how will you find I1? I1 equal to I into R2 divided by this value, R1 plus R2. I1 equal to I into R2 divided by R1 plus R2. That is, the current through the resistor R1 equal to total current multiplied by another branch resistor. This I1 is the current through R1 resistor. Another branch resistor is R2 divided by total resistor. Right? In case of voltage divider rule, same voltage, same resistor we are multiplying. Here other branch resistor we are multiplying. That is the difference. So current through resistor R1 equal to total current multiplied by resistor of another branch R2 divided by R1 plus R2. Similarly, we can see the I2 value. So I2 equal to I into R1 divided by R1 plus R2. The current flowing through resistor R2 equal to I into other value of resistor R1 divided by R1 plus R2. So in general we can say current flowing through the interested branch equal to other branch resistor divided by total resistor multiplied by total current. Only here this will be changed. Other branch resistor. In case of voltage same branch resistor. Right? Now we'll go to we'll solve the problem. So in the first problem, the circuit is available. There are three resistors available, 2 ohm, 12 ohm and 6 ohm. From the diagram it is clear these 12 ohm and 6 ohm are connected in parallel. The entire circuit is energized by 12 voltage. Right? So the total current is I ampere through the 2 ohm resistor. At this point the current is divided because of parallel circuit, current divided I1, I2. So in this problem what we need to find the value of I1, I2. This total current flowing through this 12 ohm resistor and 6 ohm resistor. and this is it is marked as point A. This is point A, point B and point C. We need to find what is the voltage across 2 ohm resistor VAB. Then what is the voltage across B and C, this parallel combination? This voltage also we need to find, right? So 3 resistors available. Out of 2 resistors connected in parallel, 12 voltage is applied, total current is I. In parallel the current is divided I1 and I2. We need to find what is the total current, what is the current flow I1, I2, what is the voltage drop across AB, and what is the voltage drop across BC. One by one we need to find. First we will simplify this diagram. So these two are connected in parallel, so we will find the equivalent resistance. So in this network 12 ohm and 6 ohm are connected in parallel. We will take this 12 ohm as R1, 6 ohm as R2. Then what is the formula for parallel combination? R equivalent equal to R1 R2 divided by R1 plus R2. R1 is 12 ohm, R2 is 6 ohm. So 12 into 6 divided by 12 plus 6. 72 by 18 is 4 ohm. Now this parallel combination is now converted into single equivalent resistor of 4 ohm, right? So this 12 ohm and 6 ohm now converted into 4 ohm. Now circuit become very simpler. This 2 ohm and 4 ohm. We can easily see that these 2 and 4 ohm are connected in series. So we can easily find the other values. So the total current I equal to V by R. What is the V? 12 voltage. What is the R value? 2 plus 4. These two are connected in series, 2 plus 4. So 12 divided by 2 plus 4, 12 divided by 6 is 2 ampere. So we easily calculated the value of total current as 2 ampere, right? I equal to V by R. All values are available. Now we can find the voltage drop across AB. What is the voltage V? V equal to IR, I into R. So VAB equal to I into RAB. So voltage drop across AB is nothing but current, total current into resistance across AB. So the total current is 2 ampere. The resistance across AB is nothing but 2 ohm. So 2 into 2, 4 voltage. Similarly, voltage across VBC equal to I into RBC. So I is 2 ampere. The resistor across BC, V and C is 4 ohm. So 2 into 4, 8 voltage. So 4 voltages drop across 2 ohm, 8 voltages drop across 4 ohm. The sum of these two, what is the sum? 4 plus 8, 12 voltage. So the 12 voltage, the applied voltage is 12. So the sum of these two also 12. So our answer is correct. Now total current is calculated. Voltage drop across AB, voltage drop across BC also calculated. Now we need to find the I1 and I2. The current flowing through 12 ohm and 6 ohm resistor, right? So this diagram is drawn again. So this is a diagram what we discussed earlier. 12 voltage is applied. So we calculated the total current is 2 amperes. This 2 ohm and 12 ohm and 6 ohm, this parallel combination available. Now current is divided into I1 and I2. So now we need to find I1 and I2. Other values are calculated. So by using the voltage divider rule, we can find this current divider rule. We can find this I1 and I2. Right? So the total current is 2 ampere. That is divided into I1 and I2. How will you find I1? I1 equal to, what is the formula? Total current multiplied by other branch resistor divided by total resistor. So I1 is the current flowing through 12 ohm. What is the other ohm? Other branch current resistor? 6 ohm. So you have to multiply with 6. Right? So total current is 2 ampere. Other branch resistor is 6 ohm divided by total resistance 6 plus 12, 18. So 2 this divided by 3 times. So 2 divided by 3 ampere. The current flowing through I1 is 2 divided by 3 ampere. So current flowing through 12 ohm resistor I1 is nothing but total current multiplied by other branch resistor divided by total resistor. We need to use this formula. Similarly, current through 6 ohm resistor equal to total current multiplied by other branch resistor 12 divided by total resistance. So that is equal to 2 into 12 divided by 18, right? So this got cancelled. These 2 and 18 got 9 times. This 9 and 4. This 9 and 12 got this 4 times, is 3 times. So 4 by 3 amps. So the total current will be 4 by 3 amps. So if we add these two, we'll get the total current of 2 ampere. So in the current division rule, we need to follow current in any branch equal to total current multiplied by other branch resistor divided by total resistor. Right. So in this problem, we calculated all the value. That is the total current, current flowing through 12 ohm, current flowing through 6 ohm, as well as voltage drop across AB and BC. These values are calculated. Now we'll go to the next problem. So in this problem, we need to find the current through the 10 ohm resistor. So there are 3 resistors available, 15 ohm, 5 ohm and 10 ohm. One current source is available, 5 ampere. So this 5 ampere, what will happen? The current will be diverted through 15 ohm, 5 ohm and 10 ohm resistor. Based on the resistor value, the current will be diverted. So in this problem, what we need to find? We need to find only the current through 10 ohm resistor. Right? Current through 10 ohm resistor is needed. But here 3 resistors available. If you want to find the current division rule, only 2 resistors are there. If it is 2 resistor, we will apply the current division rule. So in order to find this 10 ohm resistor, now we will simplify these two. These two are connected in series, connected in parallel. So we will make it as single resistor. Based on the parallel combination, we will make it as single resistor. That is 15 ohm and 5 ohm are connected in parallel. We will take this 15 ohm as R1, 5 ohm as R2. What is the equivalent resistance? R1 into R2 divided by R1 plus R2. So R1 is 15, R2 is 5. 15 into 5 divided by 15 plus 5. That is 75 divided by 20, 3.75 ohm. Right. So now these two resistors connected in parallel, that is converted into single equivalent resistance, 3.75. Right. Now we can redraw this diagram. So this is a 3.75 ohm and this 10 ohm. Our aim is to find the current through this 10 ohm. See, now only 2 resistors are available. So we can easily apply the current division rule and we can find the current through this 10 ohm resistor. What is the current through this 10 ohm resistor? I2 is termed as I2. That is equal to total current multiplied by other branch resistor. We need a current through 10 ohm resistor, mean we need to multiply with other branch resistor 3.75 divided by total resistance 3.75 plus 10. So I1 equal to total current is 5 into 3.75 divided by 13.75. So that is equal to 1.36 ampere. So current flowing through this 10 ohm resistor is 1.36 ampere. So in this problem, there are 3 resistors available. In that we need to find the current through this 10 ohm resistor. In order to apply the current rule, what we are doing, we are making these two as a single resistor because these two are connected in parallel. So that is make it as single resistor, that is 3.75. After making single resistor, we can easily identify the current through this either I1 or I2. We can easily calculate by using the current division rule. So in this problem, we calculated the current through the 10 ohm resistor. So in this video, we discuss about the voltage division rule, current division rule with the example, and we solved 2 problems based on both current and voltage division rule. Thank you.